All right, welcome to the April 26th Wednesday Joint Food Ontology Workgroup call. And today we have Magalie Weber presenting TransformON. And I've just dropped a link to the paper into the agenda for today. I thought I would mention that next month we've got next month's call is going to be really fun too. And it's involving Kate Thornton presenting on Wikipedia, and I think there's a text mining element matching to food on terms and food composition databases, WikiFCD. And then that's actually matched up with Chris Mongal, who's also doing text mining out into the world using something he's calling OntoGPT, which is using LLM language models, large language, forget what the M stands for, model, I think, and mapping recipes onto ontology terms through his LinkML specification, data specification structure. So that's going to be right down our alley, those two things together as well. Anyway, for today, let's have Magalie take us to town with her work, her institute's work. And I'm so interested to hear, I've read the paper, but I'm so interested to hear about how it's being taken up and used. So Magalie, over to you.
Thank you very much, Damien. And it's a big honor for me to present this work to such an international audience. Thank you for the opportunity. And so I will share my screen right now. I hope it's okay. No, I think I had the first screen. I don't know. It was big because I have to share my screen. I have to. Is that okay now? No. Should be okay now.
There we go. Yep.
Okay. Just a minute. I have to. Thanks. Fine. So just to. I'm not really. Here is the beginning. Thank you. So today I would like to present you TransformON, a new domain ontology on food, feed, and biowaste engineering, which is based on the PO2 core model and the EFSA FoodX2 nomenclature. And so this is a collaborative work involving several joint research units between INRAE and Agro-Paris-Tech Paris-Saclay University, which is one of the French leading stakeholders in higher education and research in the agronomic and food sector. So, sorry, I make a mistake. I don't know what I have done. So it's still okay?
Yeah, we see your.
Okay, thank you. I have not the good operating procedure. So why a new domain ontology? First, let me say a few words about INRAE to introduce why we need this new domain ontology. INRAE is the French National Research Institute for Agriculture, Food and the Environment. And it is a community of 12,000 people with 270 research units, which are located in 18 regional centers throughout France. And internationally, INRAE is among the top research organization in agricultural and food sciences, plant and animal sciences, as well as in ecology and environmental science. And INRAE has 14 research divisions, and my unit belongs to Transform, one of the research division, which acts for the development of circular and sustainable systems. So its research is put at the service of the economy of the resources and the reduction of waste, as well as multifaceted aspects of food quality. And so the food system has been defined as a set of activities and relationships that interact to determine what, how much, by what method, and for food is produced and distributed. And this was the definition by the Organization for Economic Cooperation and Development in 1981. But now we have to think about the circularity of the system in a bioeconomy and nexus-oriented approach, namely the One Health approach, which we probably know. And so in this context, we need to address new research questions, such as life cycle assessment of agri-food systems. We have to reduce food loss and think about valorization of agri-food waste. We have the process engineering and food eco-design aspects in relation with consumers' perception and preferences. And last, we have the nutritional and health aspects of food. So this is a different associated knowledge base we want to build. But beyond food, the role of research scientists in our institute and throughout the world is the valorization of agricultural and industrial byproducts. And this is illustrated here by the magnifying glass in different places on the diagram. And so research activities enable the processes design from the fractionation of agri byproduct or agricultural product or byproduct, and so to the subsequent extraction and purification of high-value molecules. And the field of application are wide, such as surface active agents, material, or bioactive molecules. And then the research activity also make it possible to increment processes for a cascade valorization, including digesters and composters that are integrated in systems, providing new opportunity for economic development, e.g. energy and heat production, or animal feed and soil amendment. So multidisciplinary approaches such as biochemistry, chemistry, physical chemistry, microbiology, and process engineering are required to ensure an efficient and complete value chain. And you have here the reference of a paper written by some of my colleagues. So the objective of the domain ontology is to describe food and bioproducts engineering from raw materials to end products, including the characterization of food, feedstuff, byproducts, and waste. So the ontology scope and purposes are the design of food quality from agricultural production to the health and environmental impacts of diets, and the design of biomass construction, deconstruction routes, and waste recycling. So we have to go towards a circular food system. So now, what are the ontology's requirements? I will show you, I will tell you give you some concrete use cases in the field of food and bio-based product engineering. For example, here are some questions we wanted to be able to answer. In the case, we want to formulate well-balanced products with acceptable sensory qualities for the consumer while using eco-friendly production processes. So, for example, what is the quantity of each ingredient being processed in the recipe? What is the unit of the quantity? Which sample has the highest value for taste intensity and the highest value for aroma intensity, for example? What are the rheological properties of this sample? What is the quantity of water and energy consumption of this sample at different steps in the process? So this is some kind of question for food. And in the case we want to formulate bio-based composites to design packaging material, we have a different question, but we have also, which I have made some color in the text to show the different type of concepts. which biomass to use in a composite with PHA to have a lower cost, what is the maximum biomass powder loading rate to keep good mechanical properties of the material, which granularity value has reached the biomass powder after a coarse milling step or after a fine milling step, such question. So we have also formulated the generic competency question. For example, here we have the color in blue, the steps or process, which steps compose a given transformation process. In green, we have the component or the input-output, which material has been involved in the process, which procedure has been used to make the observation, which attributes are associated with each steps. So attributes are the characteristics or qualities of the component. What are the attribute values associated with an input or an output for a given step of a given transformation process? And finally, what are the changes of an attribute value for an input or an output during a given step? So the list is not finished, but it's just to illustrate that we have now concept in blue, green, orange, and red, which I will show you how it is. How it is translated into concept in TransformON. And as already said, it is a domain ontology based on the PO2 core model. So what is a PO2 core model? It is a process and observation ontology, which is based on standards like SOSA SSN, time ontology, QUDT, and schema.org. It is a generic model designed to describe transformation processes, input and output components, materials and methods, observation about transformation process and input-output components. That is the measurement of the qualities we want to observe. And finally, the scales of these observations. And so, as it is a generic core model, we can extend it to some domain, and we have 7 classes or core concepts to be specialized. So I will show you now how the model is built, but briefly. This is a simplified representation of the PO2 core model, the current version. So you can see, perhaps I can take the point. Here on the top, you have in blue the concept of the process part. So a process as step, and a step as input and output components, and component can be composed of other components. Each process contains a sequence of steps, and each step has a collection of input and output components. Each step is an actuation, is a SOSA actuation. So here in green, you have the SOSA SSN concept, which have been reused in PO2. And so the observation part essentially take SOSA concept. So you have the SOSA system concept, which is PO2 materials. It is the equipment, and it is either an actuator or a sensor. So an actuation is made by an actuator and an observation is made by a sensor. And you have also the SOSA procedure, which are the PO2 methods, which are used in the process. So you also have SOSA observation are the activity which was a process which measure properties, which are PO2 attributes. And you have a PO2 observation here allows to group some SOSA observation collection, because each SOSA observation is one single value. You have some SOSA observation collection to have some table, let's say. Each SOSA observation collection represents a data table. And so you can group several SOSA observation collection into a PO2 observation. And a PO2 observation has a scale to indicate which was the scale of the measurements. For example, microscale or different type of scale we can have in the object, for the object. So the important thing is the SOSA is SSN property, and a property as an object of interest, which can be either a process, a step, a component, a material, a method, or an other attribute. This is represented by the yellow star. And finally, the third part is the result part. Each observation has a result, which can be either qualitative value or quantitative value. And when it is quantitative value, we can use the QDT unit. So, and one important thing I have not said is that each steps or actuation or observation are a SOSA phenomenon time. And so we reuse time ontology to have the sequence of action or steps. I hope it is not too much complicated, but I think it is useful to have this this diagram shown to understand the relation. But I will now show you. Sorry, I will now show you how was developed the integrative approach to reconnect agriculture, environment, food, and health, because we want to align with other food foundry ontologies to cover this large domain. But first, we have to specialize our core concept, and our main driver was data stewardship, because we had to ensure backward compatibility with existing data sets. And we want to build a federated graph-oriented database to allow knowledge integration and further modeling and reasoning. And first, we have worked on the terminology part of the ontology, namely we have specialized the core concepts, as already said, and we have to harmonize the different terminology or vocabulary used in different existing databases or datasets. And on the other hand, we have to semantize, or I don't know if the word exists, but semantization of non-semantic resources has also been done to cover the domain. So considering that FoodX2 is an authoritative reference complementary to the standard sample description used at the European level, and used by national agency in European countries for database annotation and data exchange, we decided to base the construction of PO2 TransformON on FoodX2 for the food and feed hierarchies. And in addition, we built a hierarchy for non-food products to cover the newly defined domain. So to this end, the legacy vocabulary of FoodX2 and other valuable non-semantic resources, such as the European waste catalog, were transformed into linkable data thanks to the verification process and the PO2 core model. And then we want to align, as already said, with ontology. We plan to build an ontology network thanks to mapping with above 100 ontologies. So that's the plan. So now I show you the upper levels of the vocabulary TransformON. And as already said, we have specialized the core concept of PO2, which are reminded here: component, process, step for the process part, the observation part with material, method, and scale, and the result part with the attributes and UCUM codes, which are used to standardize the units of measure, as there is an all data type property which associates a QUDT unit with its UCUM code. So this is helpful to manage the different units. So I will not detail all the branches, but just to say, to collect the terms and concepts required for knowledge representation, we combined two complementary approaches. First, we followed a bottom-up approach with the existing use cases and data sets. That is the data-driven approach. And second, we followed a top-down approach for selecting knowledge resources. So this activity consisted in looking for existing ontologies or theory that best fit the previously extracted terms and their synonyms. And we selected, of course, foodon as a main resource with respect to food, as well as other obofoundry ontologies, namely KB, CDNO, OBI, CHMO, PATO, or ENVO, among others. And with respect to the scope and purposes we define in the specification phase, we also consider the FoodX2 and the European Waste Catalog, as already said, and the EU-PAC nomenclature was also considered, as it is the universally recognized authority on chemical nomenclature and terminology. So I will not detail all the branches, but as you can see, we have distinguished for the component between living organism and inert substances, and we further distinguish between biochemical constituent, feed food, non-food substances, and a generic form for water. And in the process branch, you can observe that we have distinguished between biological or physiological processes and versus plant process to align with obofoundry. And the plant processes are further divided into characterization processes or transformation processes. And what you can see in the PO2 step, that we have listed different elementary or elementary operating actions, which are grouped from generic to more specific item. And for here you can see only the top levels, but then we can, for example, a characterization step can be a data processing step, or a transformation step can be either packaging or harvesting, and then we have detailed the branches more deeply. So I will not take too much time to describe this part, because I want to focus now on the food component, TransformON component branch, because food and feed branches were based on FoodX2 master hierarchy, taking into account the degree of transformation, and that is the branches we want to align with foodon product branch, and the non-food substance branch, which was built to include any input or output of the food system, namely the bioproducts and waste, and other non-food chemical, as well as form of water and biochemical constituents, which will be aligned with CDNO and KB, hopefully. And just to say, bioproduct and waste were derived from FoodX2 and the European Waste Catalog. So what is FoodX2? Here is an overview. It is a standardized system for classifying and describing food, as already said, complementary to the standard sample description data model used by the EFSA, the European Food Safety Agency. And FoodX2 consists of descriptions of a large number of individual food items aggregated into food groups and the broader food categories, which are organized in a parent-child hierarchical tree structure. And there is three levels. The current version was revised in 2015 and contains 3 levels of organization. So a functional hierarchy for terminology management, which is called the master hierarchy, and 7 domain-specific hierarchies. So perhaps you may know some of them, especially the exposure hierarchy, which is the same as reported in Langwall. And in addition, there is 32 facets, which are additional descriptors. They are a collection of terms which can describe some additional properties and aspects of food. So briefly, what FoodX2 is. And now we focus on the FoodX2 master hierarchy to say what was our starting point, is what is the nature of the food. And we have to follow the increasing level of processing from raw primary commodities, which are part of plants physically separated after harvesting, or animals after slaughtering. And here the processes have not changed the nature of food so much. So for example, freezing, but freezing, we can discuss about it later. But it is the raw primary commodities, either from plant or animal. And then we have the raw primary commodity derivatives, which are obtained from raw commodities applying processes, changing the nature of food. And then finally, composite foods, which can be either simple or more complicated aggregated one. And they are always obtained by multiple additives or ingredients or derivatives, and always involved recipes and processes. So that was the starting point of the FoodX2 master hierarchy, and we follow this in our food branch. And so how we have semanticized FoodX2 in our food branch of TransformON. We have taken the different groups, and we have reorganized the parent classes when it was necessary to have the animal raw commodities, plant raw commodities, processed animal product, processed plant products, composite food, that is multi-ingredient recipe-based food, or isolated purified ingredients and additives. And we kept track of the FoodX2 code and provide an URI for all classes and subclasses. So that was also the first thing. So that are the top level on the food parents organize such the increasing level of processing. And then when we go much in detail deeper in the branch, you can see that we have kept track of the taxonomy of living organism or botanical sources for raw primary commodity. We have reorganized some parent classes to have this taxonomic classification more present. I don't know. And then finally, we have also keep track of the natural source for RPC derivatives according to the degree of transformation, the type of composite food, or the type of isolated purified ingredients and additives according to the different existing lists existing in the regulation, for example. So I will not give much more details. Everything is available, and we have to discuss later on that. What to do with that, but for the feed branch of TransformON, we have kept the different categories in FoodX2, but we have just grouped feed by primary sources. We have created just a parent here to group the different classes here from FoodX2. That was much more simple. And now we build the non-food substance and recyclable waste branch. As you remind, the non-food substance branch includes all inputs and outputs of a process that are not food, feed, or food constituent. So when we focus on the recyclable waste, the construction of the recyclable waste branch of PO2 was based on existing reference systems such as the European Waste Catalogue, and we considered the non-hazardous organic waste categories. Then we defined a recyclable waste class and further divided it into recyclable organic waste or residue, or recyclable or inorganic or mixed waste. And that was to include packaging waste, for example. And the same strategy was applied as for food and feed according to the degree of transformation. Namely, we have the primary organic waste or residue, the secondary waste or bioproducts, and finally the ultimate biowaste, which are liquid or solid biowaste, such as sewage, sludge, manure, or food waste. So this was to take into account the regulation and to provide a distinction between organic or inorganic or mixed waste. So we can add as much concept subclasses or terms as we needed throughout time, over the time. So that was the principle. And now the perspective, we want to map with Obofoundry's ontologies to build an ontology network. So we have think to first to food product hierarchy, of course, but also the food on process hierarchy, which is being built. CDNO and KB, as already said, for biochemical or chemical constituents, but also, as shown in the diagram taken from the paper on food process modeling, which has recently been published in the Semantic Web Journal with Damien and all, there are some similarities between Obo plant process and SOSA SSN concepts, as you can see in different color here. And so what about devices, which are actuators and sensors in SOSA? What are the analytical procedure we can find in common? And qualities, function, roles. So the story is to be continued. So the first objective is to align the PO2 component branch with foodon, and in this way to establish a mapping between foodx2 and foodon, because we have now the URI and we have the cross database reference because we have kept the foodx2 code in our tables. And so the second objective will be to also to have a common reflection, or in common, I don't know, a common work in common or work in progress with processing equipments and measurement instruments, as well as branches for analytical procedures, measured properties, and so on. So that's the plan also, and I hope it will go well. And I found it very interesting to think about this mapping. So lastly, I present the ecosystem of tools that has been designed and implemented in accordance with the PO2 core model to create and manage domain ontologies and to annotate the data. And the first tool is called PO2 Manager. And it is a standalone application developed in Java, specifically designed to assist domain experts in vocabulary management and data annotation. And so it is based on domain ontology, namely PO2 TransformON or other domain ontologies based on the PO2 core model. And on the other side, You can the users can enter their data. So the editor offers a graphical interface, and the users can create a process and itineraries, and they enter their observation either by manual entries or thanks to files in CSV format and structures with specific template. And once the data set has been collected, PO2 Manager generates the RDF triples, and the data are published into a graph-oriented database, which we call Bagatelle, but it's the French name. And PO2 Manager also allows to further edit and enrich the ontology. And the second tool is the SPOC. It is simple PO2 query tool. And this is a web service developed to facilitate data querying from the PO2 RDF graph database. So user forms allow end users who do not know Sparkle to make queries easily by selecting appropriate fields according to the PO2 model. And so we have also an advanced usage mode where complex Sparkle queries may be defined. And the queries allow data retrieval from different projects and allows to reassemble data into new data sets, which can be then saved and exported as CSV or JSON files. And both queries and data sets can be published in open access data repository, such as the Dataverse, for example, to make them publicly available. And the tools are presented here on the website, and the domain ontology is available with a Creative Commons attribution, a CC license, and available in the open data repository researchdata.gouv, which is a French Dataverse. So that's it. I will just finish with some references and some data set. You can see that we have here in yellow the different domain we have already covered. So thank you very much for your attention, and now we can discuss if you have some question.
Great, Magalie, wonderful stuff. And I'm happy to open the floor to people. I see some questions already happening in chat, but who wants to jump in first?
Can I stop sharing because I don't see you?
Sure.
Thank you.
We could start with Troy's question, which was how much did you find the motivation to change FoodX2's hierarchy or structure into the PO2 TransformON world of ontology?
Yes. How I did find the motivation? How I found.
You made changes. What was motivating those changes?
Yes, I have made some minor changes, but it was just to group some things more logically, because sometimes I have just created some parent classes to group some other existing group in FoodX2, but I have not changed the different group. I don't know if I am clear, but it is just to reassemble some groups to keep just the raw primary plant commodities, the raw animal commodity, and then primary derivatives from plant, primary derivative from animal, and composite food or isolated ingredients. So I keep just these 6 top levels, and then I have kept the other group from FoodX2.
Okay, so FoodX2 did not have those primary commodities.
I don't know why, because in the documentation, I have read the documentation, which is very furnished, and I have I have taken 6 months to understand the logic and the reason and the explanation they have done, they have made. It is very well documented, but sometimes I was wondering why something occurred, and so I have taken I have made my own arrangement, but I have kept the FoodX2 codes, and everything is aligned with FoodX2.
Yeah. Before we move to Naomi, I just want to ask, so FoodX2 had this whole coding system. It was practically, you could put a sentence together using the different facets in a certain order to describe a food.
Yes, but it was not this kind of coding I used. When I say the FoodX2 codes, I'm just referring to the code of the group, because then you have to compose the FoodX2 codes, which is an assembly of different facets, as you mentioned. But now I just kept the code for the group in the master hierarchy. So I have the correspondence to, but I have not, in fact, the facets, I have not reused the facets as such, but I am working now on these facets to select the appropriate one to import them in the attributes hierarchy, but they are not in the food product hierarchy because they are additional descriptors. They are not the group of foods.
Okay, over to Naomi.
Yes, thank you very much. That was excellent and very interesting. And what I'm trying to bring up is, as you know, much of my presence in this meeting has been trying to find ways to harmonize globally, even though the USDA is very North America, United States centric. And it seems to me like a lot of your efforts are already dovetailing with work that Hande, Tarini, and Damien have done. And so I wondered whether or not Damien, Hande, Kyle, and Jaspri from the USDA side figure out what can be done to allow a little more harmonization for what we're trying to do for USDA Food Data Central, because much of our interest is not to reinvent the wheel, but also not to have so many different terminologies and categories that nobody will know how to really have connectivity and linkability. So that was just to bring out a broader question that I hope all of you could figure out, because I think it's critical at this point in time because of the number of things that are coming out. So that was just my comment.
Yes, and thank you for this comment and encouragement. I take this as an encouragement to go further on this way. And hopefully I will have some help from the staff. But yes, one of my motivation was also to understand why there were so many hierarchy or classification of food, because as Fudan was already in the place, I have learned much from Fudan. And so I will keep on working with the curation team, of course, but what I need to do is to have the FoodX2 reference on my side, because I have to work with many databases in European agencies have to use it. But I was wondering why there were so many different hierarchies. It is this different point of views, in fact, but with the revision in 2015, they have made a huge work, I think, to harmonize, because there is this master hierarchy now, but it is not used to describe the data. In fact, it is not. It is just used to manage the terminology. I don't know why. I suppose it is because of historical usage of different classification. But now we have this master hierarchy to guide us to map, I think.
And
So
I
with
was just gonna-
USDA, it is I really appreciate the work you have done in Food Data Central. It is a huge work, and it is an example for us, for me to to follow.
No, I mean, you know, I'm trying to find ways that Europeans and North Americans and even Canada and other parts could try to simplify the world, although I admit that it probably is job security for many. But then on the other hand, one thing that I did want to bring up, at least from our perspective, are the number of papers and issues that are coming out with respect to ultra processed foods.
Yes.
And that's, you know, where there are, you know, we just had a workshop, but there was just a recent paper trying to develop an app to decide when you go into the store whether or not you have ultra processed foods. But then on the other hand, a lot of it is the definition, because NOVA hasn't necessarily clearly defined.
Of course,
And
there is
country
much
seems-
more controversy at
Yeah.
the moment. Yes.
But it's something that's really hitting, you know, our dietary guidelines development, as well as I know the Canadian perspective. So, you know, how this can all be worked out, you know, together, to me would be better. But maybe I'm being too optimistic that we could be in harmony considering what's happening on our globe.
We have to be optimistic.
Good.
Thank
Well,
you.
that makes me, you know, it's good to hear, but
Yes, I know.
All right.
I'm also too optimistic, but
all right.
Thank
Thanks
you.
very much.
Okay.
Can I
Viviana.
just, yes, I just to give my opinion concerning this wish to standardize or harmonize the vocabulary. This initiative of FoodX2 system started, I think, 10 years ago or things like this. And the driving motivation was about risk assessment and risk management in food. So when they end, it was something about policy, and it was concerning Europe. So as usual, I think the how do you say, the area of this kind of system was not concerning necessarily United States and the other persons. So I think it's just an initiative trying to solve a European problem, European policy, European decisions, and things like this. And I think how to say, to join the initiative, it's a more political thing than researcher.
Yeah, I can see clearly FoodX2 had a mandate that Langwell reflected in terms of contamination, food contamination. And I'm just so appreciative, Magalie, that you're taking on ontologizing that hierarchy. So the clear plan is that FoodON will deprecate all of its FoodX2 food references and switch to referencing TransformON terms in their place. So we will have a mapping going in your direction, and by the same token, you guys can go in the opposite direction, and that will bridge the pond, as they say, transatlantic pond. So of course, FoodX2, I presume, has this pressure because of all the foods coming in from the rest of the world to also kind of keep up with that level of detail of food reference. And we do too. So I hope that we can end up benefiting from that. And yet our mandate is a bit more general. It's like covering research and multidisciplinary uses of food vocabulary. So there's still a role there that maybe we can help link to for your purposes. Short question. TransformON, are you going to put it in AgriPortal?
Yes, but I have not so far, in fact, because I have to do so. But it is not done. But it will be very soon because I have not taken the time to make this, because I have, as you know, we are we want the perfection before. No, but the current version is actually available in the dataset repository in Turtle. And I have to ask to my favorite IT developer which format I have to export, because I think we can directly put the TTL format, but perhaps it is better to save it as an old format. I don't know, RDF format. So I have to ask him, and so that's why I have not done so far. But it is not. It can be done quickly. But
well, we can have a side discussion about like formats Obo Foundry is familiar with, and all of that. Al functional syntax is a favorite one for the behind the scenes stuff. But just to say, once you do put it in a place like AgriPortal, then we will have those IRI
yes,
resolutions that Foodon can map to. So no rush, but that will be.
No, but as you know, I am not. It is not my expertise, but I will do what it is needed to have the mapping, of course. Right. And just to, I say that Troy has already made some comment about what is behind food descriptors and food process. Perhaps you can ask your question. And also there was many questions about my nexus-oriented approach, which is not so well known.
Yeah, Liliana was helpful in giving some definition about that, and I think she captured the spirit behind it, which is great. Yeah, so just a quick reflection, Magalie. First of all, awesome paper, awesome work. Thank you so much for sharing it with us. One of my thoughts has to do with the sort of intersection or the boundary between food descriptors or food attributes and the processes that foods go through. You know, sliced ham is a kind of ham, but it's also ham that's been sliced, right? This kind of thing. And I mean, this is not a simple topic. We don't need to answer it now, but I'm just sort of flagging for us. I think it's a good thing for us to lean into, or maybe another way to say it is, we'll know we've done our job well when we are clear on where how a food descriptor is the same or different from a food process as a food modifier. Yeah, I just think that's a useful thing for us to lean on for a while.
Yes, and I don't have the answer, of course, because it is a big question. And yes, you are right. Where is the boundary or the limit, the perimeter? I don't know. Because yes, in FoodX2, they have proposed to organize much more from what is the nature of the source, but it is categorized much more by sources, by type of sources, but it has also been organized according to the degree of transformation. So sometimes it is crossed, and we have to define which is the best way to which descriptors is inherent to the food category and which are not. And so
yep. It also has to do with how granular we find a need to mint food terms, right? Does sliced ham need to exist as its own type of food distinct from ham? Right?
I don't think so, but it is just my.
Well, that's a clear example, but apple juice is a little bit more.
But
a little
apple
bit tougher,
juice, it is a kind of product you can find on the market. So I think it is the kind of process.
Let's not discuss it now. The point is, these are examples that push us to be clear.
Yes.
Yeah, and just to say, that's a good little segue to mention that the Process Ontology group is meeting every 2 weeks. These are the topics we'll be discussing and progressing on.
And so just to say, because my scope was beyond food, and there is some question, I think, about waste, but it is also another kind of
yeah, Magalie, I'll just say one more word about that comment, which came from me. Since circularity is important for our planet, it's important to this initiative. It seems to me that maybe there's more to do about one process's output is another process's input.
Yes,
and we want that to be possible. We want outputs to be able to be recognized as valid inputs. We want the process ontology to be able to handle the reprocessing of something.
Yes.
So it feels to me like there might be a little too black and white right now in the hierarchy of the materials, that some of them are classified as inputs and some of them are classified as outputs. Just even the notion of waste, for example.
Yes. And I suppose I was not clear in my presentation because it's much complicated to explain, but in my hierarchy, there are something, the things are classified. It is always true. It is a taxonomy. I have tried to have some coherency to keep that always true, but what an input and an output is only defined at the instance level, not in the hierarchy. Because it is a matter of relation between concepts, it is not a matter of being. I'm not clear because I have just created some parent classes to explain that we can have some residues from primary processes. It is not just as I don't know some when you are processing wheat, you have some meddlings, or don't know, I don't remember the terms of the bran and so on, and that's primary, from primary process, and then we have secondary process byproducts, and then finally, ultimately, we have the waste we cannot handle. We cannot reuse in a food process, for example, and that's the ultimate waste, because the definition of waste is not so clear as you mentioned. Yes.
Right. So I think from an ontology perspective, what we would be looking for there is, yes, having upper level classes like waste, but having them so general that we never connect anything permanently underneath them. Instead, we infer for particular instances whether they're considered waste, unusable, unreusable within some process, or not.
That's why I have
they
created.
Suddenly turn out to be usable in some other process. So
yes, but I have made the parent classes only for recyclable waste. So it is not really waste, it is byproducts or residues, or anyway, it is not really waste.
Yeah, I really appreciate that hierarchy that you've got to get people attuned to how to approach this.
And all of this, after a while, is relative, right? Because you may not consider recyclable waste within your context, but somebody down the road will happily consider it as an input for another agricultural process.
Yes, of course.
So that you can't handle everything within the same model. So there is a limit to what you can and can't do.
But what we try to do is to interconnect. We have to, we describe some portion of processing as process or as itineraries. At itineraries, there are sequences of steps and there are a begin and an end. But in fact, the output product can be the input product of another process. So we have to branch processes. So in our model, I think it is possible, but in fact, you can't have the whole picture in one, but it is possible to link them through input and output components.
Okay. So I have one comment there, and then if anyone else wants to speak, otherwise we'll close it down. But comment is, if you're imagining that PO2 is going to show up in a big ontology lookup service with a whole bunch of other related ontologies in agriculture, processing, whatever, be mindful of the term labels that you've got. If they're not, if they need to be qualified so that people can look at that word and know that's the one they want out of a long list of words that might be exactly the same thing. We got that problem in in OboFoundry right now with the word patient, for example. That's just, it's a duplicated term. So that's a problem in itself. But sometimes they meant one kind of patient, sometimes another. So I just noticed that on a few of your ontology terms. They're really short labels, and that means that they might be a little, unless somebody's only looking at PO2 or TransformON, they might have a difficulty knowing that they should choose that from a search engine.
Yes, but what I have to do, but I don't want to be too much complicated, but in fact, I have all classes is also a SCORS concept, and so I can manage the terminology with synonymy and preferred label, and so perhaps it is another way to manage the label. But yes, and so we have to define the textual definition and not only an axiomatization of the. But so far the work is huge, and I have not done everything. But in FoodX2 there is some definition also. But I have to incorporate. I have to include them all.
Okay. Yes.
Thank you. Thank you all for the discussion.
Yeah, it was great. Thanks, Magalie and Liliana and all your team.
And see you
Yeah.
very soon.
Bye.
Bye. Bye.